Hey folks, this is Eric with the Additive Guru channel, and in this episode we're going to do a generative design for a simple little bracket system that would allow a person to mount to the side of maybe a desk or something so that the computer can be sort of attached to the desk. Now, this stemmed from one of our lab situations where we have some rolling desks, and they're framed like this with the wheels at the bottom. And we'd like the computer to be right here so it doesn't take up desk space and it can roll along with the desk. So what we're going to do is, and this is of course what the representative of the computer, what we're going to do is we're going to model these components, these little brackets, because the computer will sit down into the space. We'll use a screw here to kind of screw it into the side of the box, and then a screw here, and a screw going down to actually screw it into that leg of the side of the desk. And we'll have it do several of these, so we can put like one here, and maybe a third in the box to hold it up nice and stable. But we could also add, if we wanted to, instead of doing screws into the box, we could add like a little loop right here and here to allow for a bungee cord to go up and around and kind of hold the computer in place. So that way when it's being rolled around, it doesn't bounce off. So essentially we're creating a cradle, but structurally what we're going to do is build these components and then allow Generative to design in the long distance cantilevered shape to hold all this together, possibly something right here as well, because it's going to be a binding point. So let's get started. I've got a little sketch here of some dimensions. The key thing that we have is this is the incoming leg of the desk, which is the majority of what we're going to be attaching to. So this is a little section view of what I showed you below. Now if you need to, you can pause the screen at any point in time and take a look at that more thoroughly, but I'm going to walk us through the process. So first thing in Fusion, I'm going to start off with a sketch and set it up for this particular plane, and I'm going to go ahead and draw the actual shape of the desk component so that I can just work around it. So that is, and of course I did it in inches, so I need to make sure my units have changed to inches. So I'm going to come up here, document settings, expand it, switch it to inch, and OK. This will help us out a little bit. And then the measurement of this is 2.5 inches by 1 inch. So I'm going to make a rectangle that is pretty close, and then dimension it. Okay. There, that covers that. Now I also need to set this to be a contributing shape, so I'm going to select it and then switch it to the construction line type. That way I can draw with it, but it doesn't actually do anything. So there's that shape. Now the rest of it is pretty much going to be just this outline here and this outline here. So nothing major as far as the sketching is going to be concerned. So I'll go ahead and draw my line to this, to this, to this. Let's just come out, we'll say, I don't know, let's go 0.2 inches for the thickness of the wall. Actually, a better way to do that would be this way. I'll just do the outline here to here to here to here. Go. And then I'll do an offset by tapping in the O button and see if it understands that. No, it doesn't like that. Try one more time. Select there to there to there. Now try offset. Still wants to do one. Alright, so guess that's not going to work. So I'll go ahead and just draw the rest of it. Come up, come over, come up, come over. And you'll notice that I'm not actually establishing any thicknesses at this point. I'll do that right now. So we'll say that that's going to be 0.2, and this is going to be, we'll just tell it to match that by clicking on it. And we'll say here to here, put that one to match it, click here to here, and to match that one. Now, I didn't really like that scenario. I want it to be based off the bottom line. So what I'm going to do is I'm just going to delete this line and pull this down. And I'm going to help it understand that what I want is starting there and coming at point 2. Closing it there, closing it there. And let's see if I adjust it this time to that one. There we go. Now it's held. Then I need to apply some other dimensions. I need to figure out like how far out I want this leg to be. I'm thinking 1.5 inches. So I'll just click it from there to there. There we go. It wants to do the angle on me, so let's go 1.5. Now I randomly chose 0.2 as my thickness. That was just a random selection. 0.2 represent roughly around 5 millimeters, which is probably thicker than a solid feature within a 3D printed object needs to be. So I may choose to do something a little bit more equivalent to maybe 3 millimeters. So we can say that, which that would be about a 0.118, I think, something like that, 115. So, because you always remember that there's 25.4 millimeters per inch, so you can just divide your target value by 25 by 0.4, and that'll tell you what the equivalent inch value being. It's about 0.1 something. So let me change this one to 0.1. What's the 0.18? And looks like tightened everything up, but you'll notice that it did move this one as well, which is also not what I want. So I'm gonna move this one to where it lines up with that. And I'm gonna move this one where it lines up with that. All right. Now this is just things that we can adjust over time if we want to make changes, but this should give us a pretty good sense of what we're after. Next thing I need to do is come straight across from here and draw my other one. Seat going up. Needs to be the same height as that. And then this time I can probably do my offset minus 0.118. And note in the offset sometimes you have to type in negative to get to go in the direction you want it to go. Alright, so that's the general shape. I do need to establish how the distance is. It says that this thing space-wise needs to be 7 3/8 across. So I'll place it by placing a dimension here to here. 7.375. And then I want it to still have a seat of shouldn't overhead strain. See that? That's a weird scenario to want to do that. I don't really like that scenario. So to avoid the problem where it's like over constraining, I'm going to come back and just change this added dimension this time here for this line. I don't know why it's thinking it's over constrained. But that's okay, whatever. Close enough. Another way I could fix this problem would be draw a construction line from here to here and make sure this thing lines up with it. There we go. So there's that. Ooh, I didn't establish how tall I want it to be. Looks like 1.75. So dimension from here to here. And if you're creating this along with me and you just need to pause the video and see those dimensions, go for it. Alright, so now let's see if I can get this thing to dimension the position I want it to be. So from here to here, 7.375, and we're good. So now it looks like the features are in the right locations. Everything seems all right. I'm gonna click this one and show it to be the same dimension as that. Whoops, I forgot about the negative. Yeah, it's fine. Maybe pull these dimensions out a little bit so I can see them a little bit more effectively, but it looks like we are in the right plan. All right, so I finish sketch. And then of course the question of like, how thick do I want this to be? I don't know, I'd say maybe ½ inch is a little bit too small. 2 inches is probably fine. So let's go in extrusion, this, set it for 2 inches, and hit OK. And so there's my features. This is what we're going to use for Generative to make the correct support points to go with this. So I'm going to go ahead and pause the video and repeat that. Please do that now. Alright, next thing I'll do is add the holes for the screws. So I'll just click on any of these surfaces will work. So I hit this one, and I'll draw a circle from the midpoint, come down some, and I'm going to use a number 8 self-tapping screw, which is a diameter of 0.164, which you could always Google that if you needed to. I'll make it a little bit bigger because I don't need the screw to actually grab a hold of the sidewalls. It needs to screw through this. So maybe I'll just make it 1.7. And there we go. And then of course I will punch, well, I should probably give it distance down, shouldn't I? Doesn't really matter. ½ inch is fine. And then we extrude it through both parts. Alright, so there's that one. And by making it larger, it just means that I don't have to worry about like a chamfer or anything. The screw will just go right through it, no problem. Now the next thing, of course, is the 2 screws here to screw it to the sidewall of the desk. This one and this one too. Which I'll just do this one first because it's quick and easy. So I'll just come over here, click on this. Again, going from the center, coming in some, and we'll do, yeah, that's fine, 0.17, boom, and give me a dimension to locate it. 0.5 sounds good. Actually, I'm going to do 4.5, so it's a little bit further from the point here, just to make sure the screwdriver can get to it pretty easily. So there's that one, extrude. Okay, and then my final 2, which I can go from any location that I want to, need to be on that surface. So I click on here, and I draw a circle, select the center point, come up, 0.17, and then another circle, straight from it, 0.17, throw a dimension between the 2 of them. Actually, I'll just dimension from the bottom. That's fine for right now. And then dimension from here. And yeah, say 0.6. Kind of take a look at it. Maybe we'll do this, maybe not so far apart. I need to make sure I can get the screwdriver in place to get those to work. So put it there. And boom. So there's our shapes. Now our next challenge will be to get this to do a generative on it and to tell the generative software to avoid interfering with certain things. For example, we don't want it to extrude anything in this area. We don't want to extrude anything in this area, which should be fairly easy for us to do by creating obstacles. Alright, so that's good enough for right now. Go ahead and pause the video and catch up. Alright, so now we step, in that case, I'm going to step on into doing a generative report on it. I'll probably need to do a file save and all those kind of things to make sure it allows me to do that. So I'll just go ahead and do that real fast. Alright, little note when you're doing these projects and you have to store them within the Fusion system, always make sure to have very clear file names of what you're doing, so that when it comes time to search some of these things, especially if you do a lot of work, it's much easier to find. I have found that sometimes Fusion's way of organizing your projects and everything, especially when you're working with teams, gets confusing. So having good names makes a big difference. All right, so it's saved. So now we're going to switch it over to doing a generative design. And it's going to say create study. And here we go. So one of the first things we need to do is we need to set up what's going to be preserved and what's going to be obstacle, and make things to that degree. So I'm going to go ahead and do an edit model so that I can create some obstacles to be in the way of our shapes. So I'm going to go ahead and click this surface right here to draw on. And then I'm going to make a rectangle to actually fit in this location. Sometimes it doesn't see. So right there should be good. Yeah. Alright, so what we're doing is we're going to create this rectangle to fit in between it, so let it know that it doesn't need to be in this space. I tell it to finish. Okay, so finish sketch. Extrude this object, and I'm going to make sure it goes to both sides, so it knows to leave all of this. And it's not going to be a cut, it's going to be a new body, and say okay. Now I have an object that will keep it from actually interfering with any other stuff. The other thing I'm going to do is going to put one here as well. In fact, I should have probably done that in the same sketch, because I could have done it both. So I'll actually let me edit the sketch. And I'll just draw a rectangle right here. Go to sketch, edit the feature, tell it to do that too. And now it's created two things that will keep it from interfering with any of the stuff we don't want it to interfere with. The other thing I need to do now is to make sure it doesn't do any interference with these two holes in particular, and these two holes, and which is pretty easily to do. You just simply come in. I can go ahead and take care of some of these models that I've created to get them out of the way. There we go. And I'll do a start shaft. Either one of those planes should work. Now I'm just going to make it big and pull it out all the way through. I'm going to make it nice sized, so that actually I am going to hit cancel. Let me do this again. This time I'm doing this side because I want to have plenty of space. I'm going to go this way, and I want it to be fairly good size, so that way I can get a drill head or a nut driver head through this space and make it work. So hit OK. Maybe 15 might be a little bit less, half inch. Let's just go to 11. It's still in millimeters, but as long as you're able to think in millimeters and inches at the same time, you'll be fine. So pull this one through and tell it to be, pull it out, 11. That should give us enough clearance to get a driver in there to actually drive it in. I'm not too worried about this side. I don't think it's going to add stuff to this face, but it is probably going to add stuff here. So the same thing, I'm going to do that, click it, drag it up, and we'll set it to, I don't know, 10's fine, because I can easily get a nut driver through that. And here, should probably pull it through the first time. 10's fine. There we go. So by creating these, I've now created the openings that I need to get to the feature, get to the screw points, and it won't generate around it. So finish edit model. I might need to go back into edit model and turn those features back on, because sometimes if you turn the bodies off, they don't show up when you're trying to get the obstacles. So there we go. So we're going to say obstacle geometry and click on the edit button. It knows that the screws are supposed to be obstacles. And when you turn them off, they go away. You turn them back on, there they are. Preserve geometry, obviously that are good. So now it knows what those are. And we don't need to really give it a starting shape. We're going to just kind of see what it does. I do need to tell it what is fixed. So my structural constraints, I'm going to fix this hole. I'm going to fix, actually, I'm sorry, I don't mean that one. That is not one. I'm going to fix this hole because this will be attached to these three holes. Are the only things that are actually attached to the bracket or the side of the desk. So there and there and there are all it has to work with in terms of constraint. So I'll put those in lock. And then of course we need to apply loads. And this is where we're kind of like doing some guess. We probably need to think about where the load's going to be. So there's going to be probably a little bit of load on here. And there's going to be a little bit of load on here. Now I'm going to change my units to pound force. And I'm going to say that the computer is roughly, it probably doesn't weigh 30 pounds, but we'll just say it does. And it's split between the two of them. So there's 15 pounds of force on those two locations. Alright, so we've got that. So we now have our criteria of fixed points or constraints handled. We have to have our materials, of course, and so this is where we kind of be selective when we're dealing with 3D printing. And we'll choose plastic. There are quite a few plastics that are here. We don't have to get specifically additive for this to work, but it looks like it does have those. Yeah, maybe not additive, we'll just go material library. Generally when we do this, we just do ABS and drag it into space. So plastics accounted for. So we have our plastics accounted for, we have our design, we have our loads, we need our design criteria. We do want to minimize mass. Safety factor of 2 is fine. We also want to create some manufacturing restrictions. So I only want it to be additive. I don't want to overhang to exceed that, and I want minimum thickness to be 3 millimeters. There we go, we're not doing any milling. And so now it's a question of, alright, which direction in the z-axis is going to be the easiest thing to print? And looks like we got the Z, which is coming up this way in our printing direction, which is fine. I think that will work. It means it's going to print in this orientation, the same way that I was extruding it, which I don't see any issues with that, but we can always see it once it actually generates. Alright, so now we've got those handled. Let's see what our pre-check says. Alright, let's see what it says is... you see it's actually noting that some of it is interfering with it. My guess is where I didn't do a very specific where I just kind of like drew that rectangle just quick and easy. It's a problem for it. So let's see if we can generate though without it. That's going to want to. So I need to go back in and edit my model so that my original sketch doesn't. I'll pull it off just a hair and see if that fixes it. There we go. See, it's cleared now. And we'll do a test run for it to do like a quick generation. And what we can see from our preview is it's going to kind of do what we would expect. It's going to create a lot of material underneath where the desk is going to be. There's going to be some material right here, which is good. It's going to add to the supporting of this whole thing. And then of course it's giving us our gaps to be able to drill into and put our screws in with the heads. So we're going to kind of see how it generates out. One thing that I notice is that it is going to add a little texturing to the outside, which is no big deal. And it's not going, well, we do see this right here. It is going to kind of merge into my area of where the computer is going to be. I don't think that's going to be a problem though, but I could solve that. Looks like we got a little bit of it here too. but I don't think that's going to be a problem because the computer space that I allotted this is a little bit bigger than the actual computer itself, so I think it'll work just fine. Alright, so at that point in time, it would just be, our next step of course would just be to actually run it. Any changes that I see is necessary, I may decide to increase the openings of these real quick. So let me go here and I will edit that feature. I may go ahead and make it 12, make it just a little bit bigger, and I'll make this one. And the reason I'm making these a little bit larger at the bottom is simply because you need the space to get the drill head in there over top of this the actual opening of the nut, or the nut driver. So just making sure that that is available. And that I'll do another generate just to be sure.
Okay.
Alright, so at this point in time looks good, everything clears out, so we're ready to generate. And as you know, this may take a little bit, so we're going to go ahead and just kind of wrap this up and see how it goes. So at this point in time, you go ahead and I gotta make sure my account's signed in. At this point in time, you go ahead with your generate process and begin it. We'll see how it turns out.
Well, one of the things that I noticed when we did a generative on this one, I want to correct real fast, is that we did make a slight mistake in my model. So I'm going to jump back over here. And you know, when I made these obstacles, by the way, if you don't know it, you can actually drag your timeline back and forth to hide things that you've created. But when I actually created my obstacles of your connector zones, I didn't take it all the way through the hole, which does become a problem. So one of the things that I am going to do is hide some of these bodies so I can see things. And I'm going to turn around and make sure I do an obstacle in the other direction. Now I could edit these models too if I wanted to. Let's see if I can turn those back on. And not that one. Alright, so there we go. I do need to make sure that I actually add in something to account for this. And since I have two different sizes, what I can do is just add more connectors in, or obstacles in these connectors. Make sure I select the back wall, and it just has to be in this general vicinity. It doesn't have to be exact, it just has to be in there. So that one's now covered, so it knows it now can extrude anything into those spaces. This one here too. Drag it back to the surface. Good. Flip around to these sides, or this side. There's one. It doesn't matter if I go out here because there's already obstacles there anyway. So that's fine too. So now I have those holes also accounted for where it knows it can't even extrude through those spaces as well. So turn my bodies back on. By the way, if you don't turn these bodies back on, sometimes that will create a lack of obstacle geometry for you to deal with. So do a quick generate previewer. Probably should turn the obstacle geometry off. And now we can see right through the holes, everything is left open from one side to the other. So we're good there. Now with that in mind, let's try our generate. It's fine. So let me get this thing to pop away. Sorry, I had to switch my account over to education there instead of what it was defaulting to. And by doing that, I just clicked on the educational button and actually scrolled down and switched these to education 2 if you run into that scenario. And let's see what happens. Looks like it's off to the races in terms of the generation, so we'll let it do its thing. Alright, now that we have the outcomes, let's take a look and make us some selections. Now, for this being an example, doesn't really matter which one you choose. But assuming that you want to produce something that would be very effective in the process, or something that would be the type of thing that you show off to industry folks, which is a big part of what we're after, you'd want to be pretty selective in terms of what looks realistically plausible and what does not. For example, as you see as I scroll through the timeline here, yes, it converged at 32 as what it considers the ultimate solution, but you can see all the way back to 27, that's pretty thin, right? We're getting down more so than we would probably feel comfortable producing. So I'm going to pull it back a little bit. Let's take a look at 17. Well, it seems to be having an issue with 17, so let me drag it back to one of these other ones and see what happens. It may be locked. Oh, there we go. 13, still pretty thin. Let's get her down below 9. And not bad. And this might be an applicable solution, but you see where it's doing a lot of this in here. These extra holes and pockets are starting to form. It may not be structurally as ideal. Now back to 6, we have a more rigid shape, more solid, and I think this is a little bit closer to where I'd want to be in terms of performance and the overall shape of what I like. So yeah, it has this little side thing come in there. I've got plenty of gap right through where I wanted to be for my drill bit or nut driver, and I also have got a decent amount of thickness. Looks like I forgot to add the hole in right there in terms of obstacles, so that's on me. I could drill it out once we actually made it. But you can see that it's thickening up right here, which is a stress point of how this thing fits together. So I would say that I would probably pick something in maybe the 6 to 7 range of these iterations. Noticing also whichever orientation. I see I don't really like that. That's a little bit funky for me. So that would be the overall structure that I would probably choose. Now, of course, is there a different orientation that might actually benefit me? Let's take a look at one of these others. I don't think there's any major difference. Well, actually look at what it did here. This was the aluminum. I forgot to take the aluminum out of the study, so that's my fault. This is ABS plastic. And plastic shows, again, that would be one that I would choose. Back into 7s and 9s and 8s. And for the most part, this is probably actually the same overall result. Now, of course, you can't see this because it's outside the recording the screen, but it's giving me a result and saying we're still limited to a safety factor of 2 with this, which is fine. So I'd say in terms of the overall result, and of course, keep in mind it is generating in a way that it's assuming that you're going to print. So if you draw it back here, you can make some assumptions about what direction to print this thing on. So it looks like that it is planning for production in the Z direction as we selected, which is along this path here, which is why you're seeing this flat section right here, because it's assuming that this is the surface that's going to start all of this production. So it's going to build out. And then it might be able to make some of this flow, but it may have to have support material to make it work. So I still think I'm going to go with 6. So I'll probably end up running it again on the generative side after I correct those holes. But that's just a matter of me going back through the same process and doing that. But beyond that, that's kind of the selection. the selection methodology for me in choosing which one. And sometimes it's a little bit of a gut feeling. Obviously, if we're going to take this into testing, we would want to actually test the parts to see which iteration probably gives us the best results of what we're after. But it was a good little project. Now the other thing is that, I like the transparent view. Switching it to stress view, you can kind of see where it expects the stress to be, meaning that you've got ideal and high. So we got high stress zones that are a little bit more in that area. I suspect there because it's pulling against it. And probably some high stress around these points. They're in the greens. And one thing to watch for is if I take this over to the iteration 23, you can see a lot different results. It's still saying that all this is in the ideal. And when it refers to ideal, it means that your best use of material. The material is stressed to a safe degree. It's not going to fail, but you've also saved a lot of weight. And that in green technically is what you want for the best if you want like true optimization. Sometimes it's a combination of like theoretical versus what structurally is going to be most viable. And when you get too thin, industry folks are going to get a little too nervous. So we don't want to really do that. But another interesting feature is you can see like some little greens in this area. They kind of show you where the stress is starting to pop up. But that's enough for now. I recommend that you save this file. Maybe if you didn't correct your hole in the back like I did in terms of obstacles, you go fix that. But make sure that you select one of the 4, 5, 6, 7 iterations and then print that out as demonstration of your work. Thanks for watching, and we'll see you.